So I had a customer that sent me a pump that they got from Performance Engineering Solutions and failed only after 3 months. So he wasn't happy. He sent me the pump after several people recommended me. I got the pump, and first thing I noticed when I took it apart, I was really interested about this C-clip thing that he's doing. The very first thing I notice is the seal that he's using. I mean, I could push that through with my pinky. So it's not biting very hard up against the bore, which is why he needs to run the C-clip to begin with. The second thing that I noticed was, because he has this circlip, this groove machine in there for the circlip, then he's running this beveled spacer, and I'll give him brownie points for the custom little parts that he's running and shit. That's kind of cool, but it doesn't work. So this seal itself, it's kind of hard to pick up. I'll exaggerate it for you. It's sticking into this body, which means there's even less wall to seal up against the bore, which is a path for fluid to leak out or air to get in. Now, let's compare the seals themselves. I'm not sure what material this seal is or where he's sourcing them from. I'm not sure if it's an FKM or what, but comparing it to mine looks quite a bit different. If you look, I can't press that in there. I actually have to freeze this to press it in there. Not on top of that, I use a retaining compound. So you think about like gluing PVC pipes together. You can press them together and they'll be a pretty tight fit, but you're not going to rely on that alone, especially to hold back any potential leaks while it's under pressure. So I use the retaining compound. It's a much tighter fitting seal, and the material itself, it's self-lubricating. It has much better abrasion resistance, so the shaft spinning against it doesn't wear it out nearly as fast. It doesn't eat grooves into the material itself nearly as fast, and the feet per minute that this thing is spinning against it, it's rated for much higher speeds, which is especially important when you're overdriving the pump. So I don't know, even with this method that he's using, he's got to make these. He's got to have a machine a groove into there. He's charging $200 for something that's hit and miss. I don't know, guys. You be the judge of that. Okay, so taking apart his pump, I also noticed he's not replacing the piston bellow O-rings, which is actually a good thing. If you're going to be replacing these, I was initially using FKM, and then I realized that there can be a long-term problem with that, and I won't get into why. You're better off leaving these unless you're going to replace it with something better. It made me realize why the factory went with the Teflon encapsulated NBR. It's because the price of it, and for what it does a pretty good job. The problem with them is that when the Teflon coating fails, it exposes the NBR underneath to petroleum, and it quickly breaks down. but usually they're not a problem. 99% of the pumps that I see, it's a rotary shaft issue, or rotary shaft seal. So unless you're going to be replacing these with something better, which if you're going to do that, you have three options. There's Teflon encapsulated FKM, which is what I use. There is Viton Extreme. Essentially, it's FKM Viton. It's just another name for it. And then there's Calrez or Kelriz or something like that. That's very, very, very expensive. All of those options are really expensive, but all three of them, you have to have them custom made, custom ordered, and it's not cheap. You have to buy them in bulk. And then for the fuel control solenoid, what I noticed is he is replacing the O-rings on it, but on the top one, I don't know if you can see that or if it'll focus, but it was shearing on install. So, and it also feels squishy, soft, like it's been breaking down. So I don't even think that this is an FKM. I think that this is an NBR. So yeah, I don't know if the durometer was just too stiff, or if the outer diameter is too large, or what the deal with that is. But that's a problem. And then for this bottom one, he's replacing that too, but that feels like, I think that this is a silicone, just going off the color of it. This is a factory one on the left, this one, and yeah, I mean, this just looks like a silicone, which is definitely not the right material for fuel exposure. But yeah, that's my observations on the internal of the pump. The fluid was surprisingly clean, so either he put a new batch of fluid in it. I suspected that based on a video that I saw, or a post that I saw before, someone got a pump back from him, and the pump was extremely dirty on the outside. And my concern was that any contaminants left on the outside of the pump end up suspended in the fluid, which end up inside of the pump itself. So either he's seen that and taken notes, or this one happened to get a fresh batch of hydraulic fluid. I can only speculate there, but yeah, that's my observations.